So one of the most powerful messages that I got out of Dr. Bowler's textbook is to encourage the wonder in the children, and it's children of all ages, so all the way from my 9-year-old, all the way up to my high school students, and eventually, even the college students. So they referenced a few high-level mathematicians and people associated with high-level mathematics, and they said that's really what it's all about, wondering what's going on with your math problem and trying to understand it and just have that conversation. So how do we foster that in little kids? I guess that's the question I had for my 9-year-old. And for a child who's resistant to do any sort of math practice that feels like punishment, encouraging that wonder and having them wonder on their own is magical. So I actually brought up this exact math task with my children, and I used this on both my 6-year-old and my 9-year-old. And it's a 3-act math task. This is by Dan Meyer, who is referenced in Dr. Bowler's textbook quite a bit. I realize that our school district is using something similar from, I think his name is Graham Fletcher. And I'll show you that website in a moment. But this particular math task, these are designed for classroom lessons, but very easily adapted for parents or whoever's working with a child. So in this particular problem, I just want to preface with, yes, I used it with my small children. I'm actually going to use this in my high school classroom. I think this is going to fit perfectly in one of my units that comes up at the beginning of the year. So it's kind of awesome. And here's the idea. You start with a question, or in this case, a video, followed by some questions, and you just kind of leave it open there for a moment. So we would play this video. Oh, sorry if that's a bad noise for everyone. I don't know if you can even hear it. And the idea is, I'll turn it down because I can hear it. The idea is we have a bunch of coins and a coin counter. So for my children, Logan didn't know what this was. He knew that was money. He just didn't realize what they were doing with the money. So Natalie turned to him and she said, "Oh, that's a coin counter like they have at the bank, and they're counting all the coins." And we stopped the video. I didn't say anything to him about it. They just had a little conversation. And Natalie actually started with, "Oh my gosh, how much money do you think that is?" And I said, "That's a good question." So under here is the actual lesson plan for the first part of the project. Is you're supposed to ask the child, or in our teacher's case, the classroom or the groups, how much money is there and how many coins are there. So for Natalie, she understood, oh yes, because if it's a quarter, it's worth 25 cents. If it's a penny, it's worth 1 cent. She wasn't paying careful attention the first time around, so she kind of talked about all the different monetary values of coins. And this is my favorite part of a math task, is I asked the children then to write down completely, we call them bogus answers. So give me an answer that is not correct. How much money is there? And it's so funny because Natalie went with $1, and then Logan went with $1 million. So even at his young age of 6, he realized that was a really horrible answer for that question. So he kind of understood that, and it was just to get their brains engaged to think about it and to even care what the answer is, because that's kind of the challenge at the high school level also is, I present a problem, maybe they don't care about the answer, and that's kind of the issue. So then they also, on that first part of the task, get to write down what their best guess is without any information. And usually that sparks some conversation, well, it's going to be hard for me to guess because I don't really know what there is. So Natalie said, "Can I see the video one more time?" So we played the video one more time. And then she noticed, oh, there's only quarters and there's only pennies there. And that's actually was going to be my next part of the task. So I was then going to start releasing some information to them. And at this point, I'm going to be honest, Logan he lost interest. So he kind of gave up with the task, because he doesn't really understand money yet. He kind of gets it, but not really. So Natalie was really engaged. It was awesome. So I released a couple pieces of information to her, and I said, there are only quarters and pennies. So I asked her to kind of explain to Logan, because he was still sitting there. I said, "Tell him what that means." And she said, "Oh, a quarter is 25 cents. You need 4 quarters to make $1. Pennies 1 cent. You need 100 pennies to make $1. So she actually started kind of changing her estimate based on that information. Then I said, "Okay, I'm actually going to give you the answer for part 2 of our project." And they tell you this down here in the lesson plan. I think if you click on this, it actually tells you that there's 6, you would tell the child there are 1,400 coins and there's $62. So then they would look at their estimates from before and go, oh, I was pretty close, or oh, I was way off. And I said, okay, that's great. I have a new question for you. I said, how many quarters are there and how many pennies are there? So that, in its own right, can be solved with algebra. So this is where I am going to use this in my systems of equations opener, and we're going to talk about it in the frame of that for algebra. But for my little one, I said, Natalie, how many quarters do you think there are and how many pennies? And because of the way a child's brain works, they automatically will split that piece of information into something that's easy for your brain to do mentally. It's kind of amazing how it works. So I said there's 1,400 coins. So right away, and I forgot what her first guess was. It wasn't right. But she, oh gosh, I'm never going to remember what she guessed. But, she made it like a nice, even, a good thing to do math with. So she, in her brain, went, oh, I want quarters to be in groups of something that's divisible by 4. And I think she went with 400 quarters and 1,000 pennies or whatever it came out to. So we had some paper out and I said, okay, if you think there's 400 quarters and 1,000 pennies, let's figure out how much money that is. And does that get us to $62, which we know is the right answer? And then we kind of checked it out and we realized that it did not. So I'm kind of using that example here. So if it was, what did I say? 400 quarters, that would be $100, right? Can I do that math today? And then, what was I saying? 1,000 pennies would be 10. So it was too much money. And this was my favorite part of this project was I didn't say a word to her about that. And she turned to me and said, Mom, that's too much money. We're going to have to use less quarters. And I was like, whoa, because I did not expect that from her. Not that I didn't think she was capable. I didn't think she'd be engaged in this at that point. I think she would have given up because when she didn't get it right the first time, I thought she'd just quit because that's kind of in her nature, but she did not. So then she said, oh, I'm going to need less quarters. So, and then she said, oh, and then she adjusted her guess and she ended up with the right answer. And if you as a parent, if you're at home and you're like, wait, I'm not really sure what to do here. So this is where you have, if you have more children working with you, like a classroom, you would have the groups kind of work together, but then you would show in Act 3, after they've had some time to kind of talk it out, and some groups know they have the right answer and some don't. Act 3 is the answer, and it says we've got 200 quarters and 1,200 nickels, which add up to 1,400 coins, comes out to $62, and, some of the groups got there and some of the groups didn't in a classroom. For me working at home with my little ones, it was, just a matter of a couple guesses and checks and revisions, and we got it. And I was floored by how engaged they were. And Logan was still kind of sitting around hanging out with us. He wasn't really doing the math at this point. But if you think about all the math that Natalie did, monetary math, understanding values of quarters and pennies. She did some division problems, she did some addition problems, and she did all of that math on her own. I didn't, have to twist her arm into it. It was kind of great. And then the most beautiful part of it was we finished the little project, if you want to call it that, and Natalie turned to me and she said, Mom, we have a big jar of coins. Do you think we could do the same thing with this? Could we take it to the bank and figure out, maybe we'll make some estimates and wonder how much money is in there, and whoever gets closest, then we win. I'm like, oh, yeah. So it was just awesome because she then extended it to a real life example, something that, in the grand scheme of things is not going to make or break her day, but just the fact that she kind of stuck with the math and, there was no punishment for not doing it right or doing it right. And, there's no reward really. We're just doing it for the joy of math, which was kind of awesome. I'm going to be honest. So my little one, a 6-year-old, is really good at this idea of, appreciating math and kind of wondering what would happen if. Great example from him. Just the other day we were in the car and we're driving to Magic Waters, and like every parent here is on every car ride to something exciting. How long until we're there? Are we there yet? How many minutes until we're there? How many miles until we're there? And, how many? 20 minutes, Logan, 20 minutes. And then he goes, oh, okay. I wonder how long it would take if we walked there. And then that intrigued Natalie for some reason. And, I think sometimes they treat me, because I'm a math teacher, they kind of treat me like I'm their show animal, and they would just, they want me to calculate it. Like that's fun for them to watch, I guess. And I thought, no, like, let's do this together. So they wanted to know how long it would take us to walk there. And we kind of worked through the problem. I had to give them some information, obviously, because they didn't really know, at what pace they walk. They don't really understand, miles and what that means, but we worked through it. And just side note, by our estimate, because of the way we walk, we thought it would have taken us about 5 hours to walk to Magic Waters. So we decided to drive instead. But I just thought, wow, how easy would this be for parents to encourage their child to think about math problems that exist in everyday life, and rather than just, Googling the answer or, just telling them the answer, let them wonder. Let's work through it. And I know sometimes that can be annoying, but letting them enjoy the math when, frankly, when they still can, and fostering that enjoyment of math, I think would be just really beautiful for their learning. Side note, though, our school is using, let's see if I have the right thing here. It's gfletchy.com. So these are some tasks that are very similar to Dan Meyer's tasks, and they are kind of set up by grade level. I will warn you, maybe don't use every single one of these with your children, because, you want to leave a little bit of mystery for the classroom teacher. So maybe don't preemptively do all of them in the summer. But if you just need some inspiration, there's some really cool things here. I think this is the one that had the cookies. Nah, I can't remember. They're all kind of the same at this point. But there's the seesaw. I think this might be my favorite one. This one's pretty cool. I could envision kind of doing this with my kids at the park. So they show a video basically of a kid on a seesaw and a counterbalance idea, and then how many, I forget what they put, milk jugs or weights or something on the other end of it, trying to counterbalance her, and how many would she need? There she goes. How many would she need to make this work? Which then brought me to my next great idea, and I thought, what if we made our own 3-act math tasks and recorded little videos, and how fun would that be for the kids? And I mean, that's the true synthesis moment in math, right? You can create your own problem and present it to others. So just thought I'd share that with you guys. I very much enjoyed these. Obviously as a teacher, I enjoy anything that resembles a lesson plan. But as a parent, I thought, how wonderful would that be to enjoy math with my kids and not have those crying fits of drill and kill, and still get a lot of math out of them, and help my daughter and my son love math like I do and show them the beauty in it. So please share